Okay, welcome back to Pure Data Programming. We're making a wave field synthesis system. I've explained what that is in the past two videos. We're pretty far into it. It's not a difficult program to write. It's not the most complicated. Last time we had some issues with the PVU object. Basically, I have two versions of PD now, and I was using the older one, so this should create a PVU object. There we go. So last time it wasn't creating that because I was using an old version of PD. I've now updated it so I can use the PVU object again. What I need to do is connect the PVU to the outlet of this plus signal box. Now the reason we're connecting it here and not anywhere else is because this is the last place where any signal change is done. There's no volume added after this, there's no compression, there's no gain, there's nothing added after this, it just goes straight to the output. So this is the exact volume that's going to be getting outputted at. So we take the PVU object, we connect the input to the output of that box, and we connect the output to the input of the VU meter. Now, what should happen when we start our digital signal processing is we should get a reading on the PVU meter, and then if we go into edit mode or run mode, whatever, and we start to pull it up, we should see, yeah, the meter is moving. I'm not sure why this box isn't changing while the meter is moving, but this meter is moving with this. So this gives us the decibel value that is being outputted at the time. And this is useful because now we can actually see how much we're going to need to turn it up and how much we are turning it up in decibels as opposed to in the linear scale. So we're going to need to fix this box so that we can see the exact value. This just gives us a kind of rough value, but we could see the exact value from this box. So we'll need to fix that box to get it to work. And the other thing that we need to do today is to look at loading. We need to start loading files in, because that's the next step to getting this up and running. The actual wave field synthesis part works now. We need to get the files loaded in though, because we can't just do it with oscillators. We don't just want to hear oscillators all the time making rubbishy tones. We want to actually hear this output with some actual music. So I'm going to test a couple of things with this. I'm going to try attaching it. There we go. Right, it's attached. As with everything in Pure Data, it's attached to the wrong outlet. So let me fix this, and then we'll be right as rain. And I'll show you the way that this works. So, there we go. Right, let's start our signal processing. So we can hear it here, and we can see this moving here. So right now it's at minus 199 decibels, and if we start to pull it up, look at there we go. So this is how much the value actually is in decibels. And if we want to hear the other one, because remember, all these channels are oscillating. I've just not connected the PVU to them yet. So this is showing us the volume in decibels of this channel, and it will be in a minute once I PVU all of them, once I get the PVU object into all of the channels, we'll be able to see the exact value of every channel. So I'm just going to move that over a bit to make room for there, and then we'll connect this up like that. That goes in there, and then do this again. Stick the P. Let me just put that there. So a lot of the things that I've been finding with Pure Data, because this is the first time that I've used it, this is the first time that I've ever programmed with Pure Data, a lot of the things that I've found with it is that most of the mistakes that you ever make in Pure Data tend not to be with the actual logic of what you're doing, but the outlet and inlet connections that you've made. They tend to be, if you've connected the wrong inlet to the wrong outlet, or the right inlet to the wrong outlet, it's going to come up with a value that's not correct, or it's going to do something that you don't want it to do, and that's where most of the pitfalls are generally when we're working with Pure Data. It just seems to be the way that it works. There's no big sort of... I've programmed with other languages before to put it in like an easier way, and usually when you program in other languages you don't declare a variable properly, or you spell the variable wrong, or you have just made a weird function that is not logical and doesn't work. With this, everything's usually really logical and structured, and your logic's fine and stuff, but you've connected the wrong outlet to the right inlet, or the wrong inlet to the right outlet, or whatever. So now if we switch on DSP, we should see all of these meters running, and we're going to find that each time we turn this up it's going to get even louder because they're all oscillating at the same pitch. Now if we wanted to, hang on, right, if we wanted to change any of the pitches of the oscillators, we could do that. We could really, we could make some interesting music. This is how you make a synthesizer in PD. You basically make a bunch of oscillators, get them oscillating at different tones, and hit play. So now there's a whole bunch of oscillators with different tones. Anyway, that's kind of beside the point because we're not making a synthesizer. But we've got this area working now. This area works. The only thing that we have left to do is load in files. And this is where it can get a bit complicated because file paths can be really annoying. So the first thing we're going to do is we're going to take out all of the oscillators because we no longer need them. So goodbye oscillators. We're still going to leave the volume part in because we're still going to need a volume control, even though the audio files incoming might have a volume already, or they might already have been compressed or boosted, whatever. We still need to control that volume. So the first thing that we're going to do is we're going to create a bang object, right? Now there's an easier way to do this, or a more efficient way, I should say. But for the sake of keeping it simple, we're going to put in a bang object. Essentially, this is a click, right? You click it and something happens. So then we're going to put in open panel object. What this does is it opens that loading panel that you see all the time in stuff. When you save stuff, open panel. That's the panel. So I'll show you. Opens the panel, right? So this is just random stuff, games and college stuff and recordings and stuff that I've been doing. So once we've done the open panel object, we need to create this open object, and what this does is we're going to put $1 and this creates, okay, that isn't meant to look like that because this isn't actually an object. Hang on, it's a message box. I'm going to make this message box and it's called open $1. So what this does is once you select your file to open, it gets passed to this message box. $1 is the variable that it's stored as, and then we need to create this object, and this object's really important. It's called read SF, and what that stands for is read sound file, and there's a tilde after it because of course we're dealing with audio signal. So we so far have this sort of thing. Now what this does is you click on this, you select your file, it gets passed to this message box which stores it as a variable. It then gets passed to read sound file. This object reads the sound file, but the object needs to be passed another message so that it plays the sound file. To do this, we're going to create this message box called start, and basically it's going to send a 1 to the readsf message box, or object, sorry, and that's going to start the audio. And if we want to stop it, if we want to stop the audio, we're going to send it this message that says stop, and that's going to send a 0 to the readsf object, and that will stop the audio from playing. So to give you an example, we're going to turn on the DSP. You'll notice that there's no oscillators running now. What we're going to do is we're going to 0 this. These are all kind of zeroed anyway, they're not connected up or anything, but I like things to be uniform. So there we go. Right, so what we're going to do is we're going to open this. We will choose a file. We'll just choose this guitar lead1.wav, right? So we're going to open it. So it's now in here. It's been passed to here, right? So what we're going to do is start. And what we should find is that it doesn't work. No method for start. This might be because it's got a capital S attached to it. Let's try that again. So DSP is still going, and we'll go open. We'll open it. We'll do start, and there we go. It was because it had a capital. So we can see this bouncing around down here. That's because I think this track actually starts later into the song, but we can see it bouncing around. It's there really faintly. It's not very loud, but I think that's because it's coming through my speakers, which are turned down. So there's the volume. I don't know if you can hear it, but we've loaded a file in now. Successfully loaded in a file. So, the question is, why aren't we doing this in a more efficient way? And the answer is, for simplicity's sake. Because if I want to, say I want to make the open object open, and then I have to know the exact file path and the exact file name. So there's no real choice in the matter. Once you make this program in that way, it has to open the same files unless you go in and you change the file name in the open whatever thing. And we don't want to do that. We want to have some selection. So maybe we want to load in something from a different session. Let's say we go in here. Okay, not in there. Let's go in here. What if we want to open this instead? See, we couldn't do that if I had already set the file that I wanted to open. So I want this program to run for more than one session, basically. I want to be able to run different sessions through this program. So we leave it as the basic open panel, open $sign variable method, because it gives us more selection, basically. Now what we're going to do is we're going to have to duplicate this a whole bunch of times to effectively get it to sit in the right place. But we can get rid of, we'll put that up there, put these up here. So, but essentially that is the gist of this program. If you've been following along, then go try and make your own, because it's fun to tinker around with. Believe me, I've been writing this program since about December. So it's taken me a while to write. There's a couple of other ways to go about it, but I like this way because it's simple. It's not overly complicated. It doesn't need to be overly complicated. It's a little bit messy, sure, and it's about to get a whole lot messier actually, because of this start-stop thing that we have to do. But the principle's there, it works, and there is no reason why it shouldn't work. The last thing that we're going to have to do is to set the outputs, because like I said, we're going to use a different form of output from this DAC signal on every single output, because we've made the system and we've made it with 8 speakers, so we need to output from 8 speakers. Each one's going to have its own channel. Oh, I don't want to move that load bang. Come on. God. Okay, we want to leave that there. So we've got 8 channels. We load a separate audio file into each of the channels. We calculate the distance from the virtual source to the speakers, and we calculate the amplitude decay from the source to the speakers, and then we add a delay and add amplitude to cancel out that distance so that we have our virtual sources. It sounds like the sources come from behind the speakers, the sides of the speakers, in front of the speakers, wherever you want them to be, behind the listener, beside the listener, wherever. So that's the general idea of it, and it's not a difficult thing to implement. It's, you know, but it's a good idea, and it's cool, and it works. So what we're going to do is set up the outputs. What we're going to do here is we're going to make we're going to tell the program that we have 8 speakers that we want to output to. So we're going to do our DAC, and we're going to do a tilde, and then we'll go 1, 2, 3, 4, 5, 6, 7, and 8. And there, it's created the 8 inlets for each of the speakers. And what we do is we go from left to right, and we just connect each one to a speaker. There we go. And there's the last one. And there. Right, so that's it, essentially. That is our program. It achieves wavefield synthesis. What we need to do when we just turn that off. What we do when we actually want to hook it up to all the speakers is we're running it from an 8-output interface. So each of the speakers has its own output on the interface. And what we do inside here is we go to the audio settings, and we change the output device to our audio interface, which I will switch on, and you might be able to see it inside of here, but maybe not, because it's not plugged in. That's why the USB cable's not plugged in. Let me plug it in, and I'll see if I can get it to connect up. There we go, it's connected now, and we'll see if we can... There we go, see? So we would select the audio box as our outputs in here, output device, we would go audio box ASIO driver, and input device would be the one that matches. And then we would change the channels to 8, because it's 8 in, 8 out, and then we would connect the speakers to it, and it would run out of those speakers. And I'll probably have a video somewhere on this YouTube channel of the speakers running from the output from the audio interface. So that is my wavefield synthesis program. I hope you enjoyed watching me build it, write it, create it from scratch. Yeah, that's it really. Thanks for watching, and bye.